So thank you for joining the community call on December 8th. We have a few topics to discuss today. Naya is going to talk a little bit about OpenTelemetry updates and things that are coming. Then we'll see a demo of Dapr and Couchbase. And finally, we want to really give an opportunity to ask more questions and open things for discussion. And I know there's a few other things that specifically the community we'd like to have a community discussion on. So yeah, so please stay tuned for that. Without further ado, I'll kick it off with Naya. So let me stop sharing. Take it away, Naya.
All right, hello everyone. I'm gonna share my screen now. Can everyone see this?
Yep.
Okay. Yeah, we see it.
So yeah, welcome to the community meeting. I am very honored to present to you some of the change that we made in RC2 about OpenTelemetry. And they're mostly, and also I'll give an update of the common change that come after RC2 as well.
So maybe a quick word now before you get started. So we did release RC1 last month, and RC2 is coming up. So this will be included as part of that release candidate, right?
Right. Yes. So so the thing that I showed today is not yet released, but should be released in a couple of weeks. All right. So let's see. How do I hide this? All right. So we plan to support the two tracing format. So the first one that we support will be the OpenTelemetryTrace protocol, but this is it is a CMP format, and it an industry standard, but it's in development. It won't be GA until 2021, and so even though we want to support it, we won't do so until it is a GA protocol. And before doing so, though, we will use Zipkin as the interim standard that we support in Dapr. The reason why we chose Zipkin is because it is the most widely supported trace format today. After OpenTelemetry trace protocol is GA, we will support both Zipkin and OpenTelemetry going forward. That will ensure that we don't break any one that is using Zipkin today, and will allow user to have time to move to OpenTelemetry on their own agenda, and also when OpenTelemetry is mature enough. And in the meantime, if you have any monitoring tool that does not support the Zipkin protocol, there is a workaround using the OpenTelemetry collector agent. It can talk, it can speak, listen to the Zipkin format, and it can write to any almost all other trace format. So for example, writing to application insight.
Oh, Naya, I think you're muted. Oh, okay.
Okay, I think somebody muted me. Can you guys hear me now?
Yeah, we can hear you.
Okay. Did I go through everything? I mean, was I muted?
I think we just missed one sentence.
Okay. Yeah. So yeah, an example of the tracing backend that does not support the Zipkin protocol is App Insight, and in the meantime, if we want to use it, then we can use the OpenTelemetry collector agent, which is basically a universal translator for trace. That was the long-term change we want to make, the longer plan. But in RC2, the immediate change that we make is that there is no longer an exporter component. And instead, all the tracing parameters or setting will be moved into the configuration object. if take a look at this snippet right here, the green line are the new line, the new parameter we add into configuration in the tracing section. The only new field that's added is the endpoint address for the Zipkin Zipkin server. Uh, so it doesn't have to be Zipkin, but as long as the server accepts the Zipkin protocol, then it is usable this way. So an example of this usage is very easily done through our observability quick start. I will go through a demo of this. This is actually the easiest demo because once you install Dapr on localhost, this can be done right away. Can you see the font on my screen? Is that too small, or is that it need to be bigger?
I think if you can make it a little bit bigger, that would be good.
Okay, let's see.
For people without a big screen.
Is that good?
Yeah, that's better.
Okay, so let's take a look at the Dapr config directory. You can see that the Dapr config, the default configuration that's shipped with Dapr on localhost is now having these two lines already added. At the same time, in the component directory, you will see that the previous version zipkin.yaml is now not shipped. So if you're upgrading from an existing installation, you will need to do those steps yourself, deleting the Zipkin YAML component and add those two lines into the config YAML. And because Dapr on the self-hosted mode ship Zipkin, run this Zipkin automatically for you, there's not much that need to be done. Just run your app. So here I'm running the server, and then run the client. Here you see the server is talking to the client, and then go to Zipkin. Trace should show right away. You can see these trace was from a few seconds ago. We could also look at the dependency graph to see that the client Python app is talking to the node app right here. So let's connect that up. So you can see that the Hello World demo on localhost is almost identical as before. If you install a new installation of Dapr, if you upgrade, you have to do a few changes, but only two lines and a file that need to be deleted. In the future, when we support the OpenTelemetry protocol, we don't have to use the Zipkin protocol to talk to Zipkin. We could use the OpenTelemetry protocol as well. But this is not doable today. This is a plan of future after OpenTelemetry is GA. And the same thing could be done on Kubernetes. The observability quick start also show an example of setting the same setup on Kubernetes. You run Zipkin as a Kubernetes service, and then Dapr Cycle will talk to Zipkin using that protocol. But because the Zipkin protocol is understood by many backend, it's easily you can swap in Jaeger. Later, I can share the slide, and these have linked to example that we use Jaeger to show trace, and nothing has changed in this picture except that the server is swap out, and you update the configuration to point to the Jaeger server instead of Zipkin server, but it's still speaking Zipkin protocol. The same thing can be done with New Relic. That speak to the ubiquity of the Zipkin trace protocol. Last week we have, in the last call we have some demo using New Relic, and the Zipkin protocol can be used. There's no change needed from our code. again, later you can go through the instruction yourself from this link. Or this last case is where we want to talk to something that does not understand Zipkin. For example, application insight. I think Stackdriver might understand Zipkin, or basically any other thing, because if you follow this link, you see that the OpenTelemetry collector can talk to like 20 or 22 different backend and understand almost all of them. Most importantly, right now, they understand the Zipkin trace protocol. So just by supporting Zipkin, we basically can talk to anything that the OpenTelemetry collector can talk to. And I will in the future, when OpenTelemetryTrace protocol is supported, there's a plan from the app inside to understand OpenTelemetry directly. Then there's no need to have an additional hop from the collector to app insight. And we expect the same to be happening across other backend as well. As OpenTelemetry become the industry standard, more and more backend will understand OpenTelemetry directly, and then no need for translation. So the last demo I want to show is using the Zipkin protocol to export to OpenTele Connector, and then that export to App Insight on Kubernetes. So let's take a look at the change that needed to. I also linked the PR in here to show the instruction. Basically, we set up the OpenTelemetry collector to talk to the Zipkin, to receive data as the Zipkin format, and then we export the data to App Insight format. And here I also add a logging. We should not do this regularly. This is only for instructional purpose, where the login is very useful. You can look into the collector log to see that the trace has been received. And so all this YAML is to set up the collector. And then the configuration only need to point to the address of the collector agent with the path for the Zipkin API. So let's do that. So I already started here the calculator, distributed calculator app, and in the show the change that we need to make. See the same thing, pointing to OpenTelemetry collector agent. And now let's send some traffic to the calculator front end. So here I have this open. So just you need to send a bunch of traffics, like unlike the case of the Hello World sample where the client is automating the traffic sending. Here we click a bunch of time. The more the better, because sometimes I see that with not enough trace, it does not show on it doesn't show very well on App Insight. So let's take a look at the log of in the last minute. You can see that trace has been received by the OpenTelemetry collector agent as shown in the log. So it will take some time to show here, but basically the tray has shown. So for app inside, it usually takes a little bit of time before the application map shows the call correctly. So you can see here, calculator is making a bunch of calls to different apps, as well as call the state store to store the state, and yep, all that goodness. So you want to look further to see the changes that are coming. The main tracking issue is the 2337. It has everything in there. Or you can look at individual issue here. Most of them are check-in already. There's only 1 or 2 left. Stock issue. And then, yeah, and then the rest will be blocked until OpenTelemetry is GA. All right.
Great. Thank you, Naya. Just maybe a few things to say here. So this again is something that's coming to RC2, right?
Yes.
And will be coming soon. And it's actually part of this progression we're making towards OpenTelemetry, because it's not exactly fully baked, I guess. Then we need to take these kind of steps in the right direction. And for me, what was a little bit confusing in the beginning, when we first talked about this part of this call, was that there's right now we're using there's the protocol you're using, and then there's the tool, right? And then we had exporters in the middle. So now the change is kind of to get rid of those exporters. We're still using the Zipkin protocol, and in the near future we'll be able to use anything that kind of understands the Zipkin protocol. Which Jaeger understands, and of course Zipkin understands. But then when we move to OpenTelemetry, that's going to require some additional kind of maybe steps. And then finally, our goal is to kind of move to OpenTelemetry is going to be the standard, and then hopefully everybody will understand it, and we'll all be happily living happily ever after, right?
Yes. So
yeah.
Ideally, if OpenTelemetry is everyone understand it, then yes, we'll probably only need to support one thing.
Right.
But
right.
If it's not ideal, I think we do the next best thing for the user. We'll support both protocol and cover all the cases, I think.
Right. I just wanted to give context a little bit to the community, because this is kind of a tricky time we're living in, and we're trying to kind of mitigate that with these steps. And hopefully this was clarifying to everybody. And of course, once RC2 comes out, all these instructions that Naya just showed today are going to appear in the docs, and for that specific version. And that's part of the cool thing that we have with the new docs, that if some of that stuff does not apply to an earlier release, then like the instructions and guidance changes accordingly. So thank you, Naya, for this. This is super helpful, I think, to understand the transition and what's coming up. With that, I'll kick it over to Yaron. If there are any questions, please put them in the chat, and we can get them to them at the end of the session as well. So Yaron, take it away.
Yeah, let me just share my screen. Let me know when you can see the Dapr docs.
We see it.
All right, great. So first of all, thanks, Naya, for the explanation. It is a tricky time because we're waiting for OpenTelemetry to really be the industry standard that it's meant to be. And until then, we really need to support existing protocols and users of other systems that don't support it yet. So I think the most important takeaway here is that Dapr will do its best to support both and support all users on all platforms. So I'm going to be talking today about Couchbase and Dapr. So if you've been using Dapr, or if you've looked at our docs, mostly when you're running Dapr locally, it's pretty synonymous with running it with Redis, just because Redis is very well known and it's easy to install unless you're running on Windows. But if you're running on Docker, then that's not a problem. But today I'm actually going to show you a database that I personally really like, which is Couchbase. We've also seen some users using it with Dapr. And I think there are many benefits to Couchbase, both when running locally and in a distributed environment. So first of all, Couchbase is a pretty cool tech. It'll allow you to do automatic sharding. It calls them virtual buckets, but that's just a fancy name for partitions. It'll do automatic partitioning server side. You can add or remove nodes from a clustering, and it can run locally pretty easily too. And it has a whole bunch of analytics and metrics that are pretty useful to you, whether you're a developer or an ops guy. And I just want to walk you through how to get Couchbase and Dapr running locally and see some of the stuff that Couchbase allows us to see, and also benchmark it pretty easily. So let's go ahead and get started. So I'm in the Dapr docs here. And if I am searching for something, then I can just do Couchbase. And we have this really nice search thing here in the docs, and it'll just lead me to the Couchbase documentation. And let's just follow the docs. So here I can just run Couchbase locally with Docker. Let's see if that works. Should. All right, so that's basically it. If I do Docker PS, I can see that Couchbase is up and running. Let's make sure that it stays up. Yep, looks like everything's okay. And if I go here, then the next step really is to start interacting with Couchbase. So Couchbase will need a slight setup. So I'm just going to open localhost 8091, which is the default port for Couchbase. And I'm just going to set up a new cluster here in a sort of a wizard install thing. So I'm going to name the cluster your own 2. I'm going to name the admin your own 2. And then for the password, I'm going to be really original, and I'm going to specify your own 2, your own 2. All right, so these are the terms, and I accept them. And here I'm just going to remove the analytics service memory quota because I don't need it, and it's just taking up a lot of space when I don't need it locally on my development machine. And that's basically it. So I have the dashboard, but it's pretty empty. So Couchbase has the concept of buckets. The next thing I'll do is just create one. That's very simple. I just press add bucket. I'll call it test, and I will just add it. And we can see that currently it's pending to be added to the single node that I'm running on my machine, and it's basically done. I can see all sorts of stats here for it, and that's basically it. So the next step and final step really is to create a Dapr component for it. So it has the Couchbase URL, the username, the password, and the bucket name, all of the things that I just configured on Couchbase locally, and I have it here. So I just created this YAML here with the URL and everything that I've just gave it. So as a developer, I want to run just the Dapr sidecar now and test Couchbase, and I don't want to write an application to do that, right? Because Dapr is a sidecar, and we always talk about Dapr in the context of having an application run next to it. But really, all I want to do is just start the sidecar, maybe as a gateway, and then start the database and then load test it. So not a lot of people know, but you can actually do this. You can run Dapr just as the sidecar without the app running at all. So here I'm using the Dapr CLI, and I'm doing Dapr run with app ID test. I'm specifying the Dapr port, and I'm giving it the components path, so the directory, and that'll run Dapr. So Dapr is running. It took it 17 milliseconds to init, and we can see that we loaded the state store, which is of type state.couchbase, and we can't see any visible errors. So what I can do now is just go to Postman and target the Dapr state API, where I'm saying, hey, target the state store and save this simple key value. The key is order ID, and the value is 5. So I can save that, and we can see pretty low latencies here. And what I'm going to do now is just use AB to do some load test on it. So I'm going to be completing 50,000 requests from 32 client connections. And I'm basically calling the same localhost address with state and the state store. And then I'm saying, hey, just fetch me the order ID. So that thing's going to run. And it looks like it's about 5,000 requests per second, I think. We'll wait for it to finish. But if I go back here into my dashboard, I'm not a person to easily fall to things, but when I do, it's for nice graphs. but the graphs here are actually quite useful. We have cache miss ratios, get sets, delete rates. That kind of stuff you don't normally get with Redis. So you get it with Couchbase, and you can set up your indexes, you can query, you can view more advanced analytics, which I disabled, and you can also get events from the database. So that works on your local environment just as it would on a distributed environment where you actually join nodes to the cluster. So this is quite nice. And if we go back here, we can see that we finished and we have pretty low latencies. And we did it with 5,247 requests per second. And that's with Dapr, the load test client, and the database all running on the same machine. So if I wanted to, for example, do benchmarks for different kinds of key value stores, I wouldn't need to change anything in my test suite. The only thing I would need to change is just replace this YAML file that I have, which is the Couchbase YAML here, with the YAML for the database that I'm testing, and I would just rerun the A/B test, and I could get pretty good stats, whether I'm testing it locally or whether I'm testing it in a Kubernetes cluster or just in the plain VM. And that's it. So if anyone has any questions, you can ask now.
Yeah, I think we have a question from Philip. He says, so this is cool. Does that mean that you can have a bucket per component type, i.e. one bucket for state, one bucket for actors, one bucket for pub/sub? Also, does Couchbase support everything required for Dapr components? I believe you showed state, right? Right now.
Yeah, so good question. Let me start with bucket for pub/sub. So Couchbase is a database. It's not a Dapr pub/sub mechanism. If you really wanted to, you could build some pub/sub mechanisms around Couchbase, but I don't recommend that. So the Couchbase implementation currently does not support transactions in Dapr. Once it does, you'll also be able to use it for actors. So if anyone wants to pick up the work and extend Dapr to have Couchbase support transactions, that'd be really cool. Now it doesn't support actors.
Okay, great. Any other questions? Yes, we are moving to the open discussion anyway, so feel free to drop anything. We can also unmute you if you have a more complex thing to say, or if you want to chime in.
Oh, but sorry. So the question is, yes, you can have multiple state stores with multiple buckets. I think, Philip, you also asked about that. So you can create multiple apps targeting the same bucket if you're using one component for multiple apps, or you can create as many Dapr components with different buckets, and then you can have different buckets for different applications, which, if supported actors, would basically say, hey, you can have a separate bucket for my stateless services, and I can have a separate bucket for all my services that actually use actors.
Okay, cool. Thank you, everyone. And thank you, Philip, for that question. Anything else that people want to discuss? Feedback on the RC1? Any other things to share, to ask? Proposals, suggestions, questions? Question on when is GA expected? Well, yeah, that's that's, I guess, a good question. As you can tell, we are doing this kind of iterative approach as it should be to release candidates towards version 1.0. I think our goal is to get to the last release candidate, and then finally the official one in the next few months, the early months of 2021. So, but of course, this has to go with how the release candidates are progressing and what kind of issues we find, and so forth. But we believe this process will be in the first quarter, I would say, of 2021.
Yeah, I think the answer we can say is we have a release candidate coming out next week, which we're excited about. That's RC2. Then you'll see another one in January. And then, we're pretty confident that we're on track to get a GA in the first quarter of next year. So, at the latest by the beginning of, by the time we get to the beginning of March, I think that's where you're going to see it. So we're not far off. That's why please try this all out, give us feedback. Now's the time to affect the features that are in the product. And that's why we're doing lots and lots of work on perf and scale and unit testing and load testing and things like this. And that's where we really need feedback on scale and deployment of real projects.
Yep. Okay, so we have another question on tracing, I see. Yeah, so about tracing, so Trond asks, as far as I can see, Dapr's tracing implementation is fairly black box. I'd like to send new traces to existing spans or add trace metadata from within my app. Is there any plan to open up Dapr's tracing mechanism so that apps can utilize it as well?
That's a really good question. Actually, it came up before in an issue that someone opened on the Dapr repository. And there was a discussion whether to open tracing as an API for users. So, so that you can call in with your application traces and not just the Dapr related traces and trace your own custom events. So that's a good thought. If you can find that issue, or maybe I can find it and paste in the chat window and we can keep the discussion going there, that'd be great. Other than that, if you're using your own SDK to instrument your code, then Dapr sends the tracing IDs. And if you're using the same tracing backend for your application and Dapr, so you can do correlations. You can, for example, use the same tracing ID for an event that you're sending from your application, and then it'll get correlated. So you can do it like that.
Yes.
The benefit that I see with the issue that was opened is that you won't need any sort of SDKs to instrument your code if we just open it up as an API for users to call into.
Tron, I don't know if that answers it. I can also unmute you to see if you want to jump in. Feel free to unmute. I think you should be able to.
Hey guys, I don't know if you can hear me okay. I didn't really.
Yeah, we hear you. Yeah.
Oh, okay, good. Yeah, so I was actually not aware that if Dapr kind of pushes the tracing headers into the application via the kind of request response model, that's all we need. We're fine to kind of use the tracing SDK inside our app. We just want that correlation between the Dapr traces and the in-application traces, so to speak. So if that works out already, then that's all I need at least.
Yeah, and Trond, let's talk on Discord, and I can give you like a code snippet sample or talk
Awesome.
about how that's being done.
Awesome, thanks.
No problem.
Okay, anything else? So Yaron, I think you wanted to discuss something as well?
Yeah, so hey everyone, Ryan and I were keen on getting some community feedback and really open up a question to the community about the service invocation building block for Dapr. So if you don't know today, Dapr offers an API where applications can call other applications and Dapr through Dapr, and Dapr really acts as a reverse proxy plus service discovery type of component, and it does traces and metrics, and it retries in the event of network partitions and network failures, and it encrypts the transit with a mutual TLS, and it does cert management rotation for you, really much like what a service mesh would do, only there's a couple of benefits here in that you explicitly call the Dapr API, which means that Dapr can do service discovery. So if you're running locally, it'll do multicast DNS for you. And if you're running on Kubernetes, it'll just abstract away all of the Kubernetes networking from you, and it'll abstract away the need to hook up services into your deployments and figuring out how Kubernetes does fully qualified DNS name resolutions. And we've been hearing that from some users that they also want Dapr to do transparent proxying in the way that a service mesh does, where you already have your target address figured out, or you have an ingress, and then you will just call it, and Dapr will transparently intercept the traffic, will not do service discovery because it's traffic that does not flow to Dapr in the first place, but it'll hook up the MTLS and tracing and metrics and all of the other features to the network traffic that's going in transparently. So essentially, having Dapr do transparent proxying on layer 7 to begin with. So let's say for HTTP or gRPC, which is based on HTTP2, and then in the future it might fall all the way back to just TCP connections. So we're really keen on hearing about if you think Dapr should do that, if it should go that route, if you'd be interested in seeing that, and the floor is now open to everyone else.
I just want to add, this is Ryan, by the way, I just want to add one thing to there. I mean, my sort of thinking about this starts with looking at the invocation building block and saying, is there a way that we can have all the benefits of the invocation building block, but allow things like the code generated gRPC clients and servers to work, and have Dapr in the middle providing tracing and security and all the things that it provides, but make more of people's existing code and existing patterns work without sort of injecting Dapr and how your apps communicate with each other, if that makes sense. So curious if folks as well have scenarios that they think aren't covered well by invocation today, or have sort of ran into scenarios where it's like, I really wish I could do something that this doesn't do.
Okay, so Lynn says yes. Well, so Lynn, about the let's get it done, feel free to submit a PR.
How did I know that's what you were going to say? So Barkle and I were talking about this last week, and then we had some more conversation about it yesterday. And I think this is huge in my opinion, and this is something that will unblock adoption, especially for brownfield development, yes, right? I mean, because especially with gRPC, with HTTP, it's a little bit easier. But with gRPC, it's a bit of a mess right now because you have to use the Dapr protos rather than your own apps, and which means you're going to recompile stuff, and it's not pretty necessarily. And so yeah, being able to just have this act like a traditional service mesh that's just going to transparently hook itself up and provide that MTLS, but then also put its hooks in there for the distributed tracing and telemetry, in my opinion, is a game changer. I think it would be huge.
Okay, and I can already see that Xavier, Trond, and Philip have some sort of consensus around not doing that. So Trond says, wouldn't that be very similar to what service mesh projects do? Yes, it would. I think if Dapr were to do this, it'd probably be an opt-in thing. It wouldn't replace the current service invocation building block. For example, with transparent proxying, what the service mesh won't do for you is do this service discovery for you. That's something that you couldn't get just with transparent proxying. So Tron continues to ask, wouldn't it be better to build a really awesome integration with Istio, etc., than to implement parts of service mesh functionality? So, today you can run Dapr alongside Linkerd. I think we've shown this in a community call. Maybe it was the 14th one. I don't remember. If anyone can put the URL here, that'd be great. And I actually know personally users who run Dapr with Istio. So, it does work. So this scenario where you want to target Dapr for its higher level APIs that service meshes don't have, like secret management, state, and pub sub, and all that jazz, and then let the service mesh do your transparent proxying, that'll work. On the other hand, if we could add that to Dapr, where you could basically, say, hey, I want Dapr to operate as my proxy, and then you don't need the burden of running or operating a service mesh. And I agree with Xavier here that, simplicity is really important for Dapr, and we're trying to keep it really simple. And service meshes have a lot of complexity. So if we can keep the simplicity of Dapr, but then allow it also to do the service mesh stuff, I think that that can be quite useful for many users.
Might be might be a dumb question, but why can't it leverage Dapr service discovery?
Sorry?
I said it might be a dumb question, but if we had proxy, why can't it leverage?
Yeah, because Dapr has the concept of an ID. So when you call it with an ID, it'll use a pluggable name resolution component to basically say, hey, I'm now running on just run another, right, Kubernetes. So I'm going to do a naming resolution for a Kubernetes DNS. And if you call Dapr with an ID that's, might run on, I don't know, Google App Engine, then it'll resolve it to a Google App Engine URL. With if you have an existing application that calls another app, it should already know where it's located. So the service discovery part is really on the application itself, because Dapr has no idea about the contents or the URLs that's going in there. So there's really no way in letting it know which application you want it to target. What the service meshes transparent proxying gives you is really the ability to not change your code at all. So if you don't change your code, then you should already know which endpoints you're going to call in advance. Whereas with Dapr, it's always localhost and the ID of the application you want, and then Dapr will resolve all those service discovery for you. So that's the only major difference that I see.
Yeah, another possibility that I've that I've thought of, and I've even built like the world's worst version of it, would be doing something that's a little bit of a hybrid that's in between. So I think the possibility also exists to do a hybrid approach, that it's not a fully transparent proxy. It is something that is that's coupled to Dapr and is coupled to Dapr concepts, and still involves you, say, like writing a URL to localhost. Like, for the most part, I don't want to get sidetracked too far, but for the most part, rewriting URLs of requests is a pretty safe thing to do in terms of implementing it in a structured way. And it seems reasonable to be able to proxy between different applications, sort of like a different flavor of the invocation building block.
Yeah. The only thing I'm seeing is that you'll need to rewrite your URL for that, which is maybe what you meant in the hybrid mode. Yep. And yeah, so for brownfield, it won't be like take my code as it is and just inject Dapr inside of it for transparent proxying as you would with Envoy or Linkerd. So you would still need to change your URL, which, depending on how people see it, I guess it could be done. Or, it can be a header or something, but yep. usually when people use Envoy or Linkerd, they already know where their service is going to live. They already know the address. George says, anything that makes dealing with gRPC easier and requires less work is a distinct benefit for Dapr. Yeah, so actually one of the things that I like about how Dapr does with gRPC today is that you can really call on gRPC endpoints from using HTTP or using just the SDKs with a really simple method that says, hey, call the ID of this service with that method name, and then Dapr will invoke the target application. The only, I would say, not so simple side here is from the application that's being called, where today it needs to implement a specific interface required by Dapr for gRPC. But we are looking into how we can transparently proxy those requests into gRPC. So you could take an existing gRPC application and Dapr will masquerade listening to its service interface. And so as the callee application, you won't have to implement the Dapr gRPC proto service. You'll just be able to use your own, let Dapr know that it exists, and then you'll be able to transparently call to your service application. So that's something that we're looking at also. Yeah, I agree, George. And so this is quite a nice topic to touch on, because service invocation could go many ways. So Trump says, regarding service invocation, it's my impression that rate limiting is implemented on the receiver side, which means the scale out after service invocation are invoked won't help since the request is already homed. So with rate limiting, if you scale your app to multiple instances, the rate limiting settings will apply to each of your instances, if that's what you're asking. It's probably a different discussion. Okay, Ryan or anyone else, do you have anything to add? If you go to the Dapr repository, by the way, there should be an issue about transparent proxying or service meshes. And if there isn't one, we'll open one to make it visible to the community and just start the discussion there and see how everyone sees this.
Cool. Thanks everybody who shared your feedback as well.
Yeah. All right, so Ori, back to you, I guess.
Yeah, thank you for that good discussion. Wait 1 second. Yeah, so I don't know if anybody else has any other questions or comments on any other topic as well. Feel free to drop them in, raise your hand. And if not, we can close this one earlier. Archer, did you want to say something?
Yeah, just wanted to say something on the Java SDK part for tracing, but it was a past discussion, so I could not unmute myself. So I sent the message in the chat. Thank you.
Oh, okay. Okay, so looks like we're done for today. In 2 weeks, we're gonna skip that community call just because it lands right in the holidays. So we'll see you. I think the next one will probably be in 2021. So thank you so much, everybody, and happy holidays if you are observing them. And thank you. Have a great day, morning, evening, wherever you are. Thank you.